Welcome to the Stormsurf video surf forecast for the week starting Sunday, June 16th. Looking at significant wave heights for the South Pacific Ocean, we see a pretty quiet pattern going on. Looks like maybe high pressure here, driving winds to the south into Antarctica. Another little gale maybe driving 20-foot seas, but I mean nothing of any significance. And we believe this is all attributable to the inactive phase of the MJO taking control of the atmosphere, but just for a little while. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when those gales do form, help direct their track. We're looking for a trough, that is, winds pushing to the north in the southern branch of the jet stream, right like there. That helps form a clockwise circulation aloft, and in the southern hemisphere, it means low pressure. It also manifests itself down at the surface, and of course low pressure generates wind, winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a trough. It actually extends really well to the north, up to like 40, 38 north, something like that, but it's really kind of pinched, you know. It needs to cover a broader area. Instead, it's this kind of pinched trough thing. Probably not a lot of good support for storm development. And part two, relative to California, Southern California's swell window cuts off right about there, and it's right on the hairy edge of that. So probably not super supportive. What is really noticeable here is a broad, looks like to be high pressure aloft, just mashing the jet south, not even over the ice line. And the Ross Ice Shelf is down here about 65 south. This is down into mainland Antarctica here, just offering literally no support. This is basically what they call a ridge when the jet is pushing south like this, and that is sweeping off to the east. In fact, let's put this in motion, take a look. And there you go. You can see it sweeping to the east, pinching off this trough even more as we get into Monday. The ridge continues, kind of maybe offering a little bit of a break Tuesday, but no, here comes reinforcing winds into Wednesday. I mean, this just doesn't look good at all, but this is all really typical of the inactive phase of the MJO. That's, you probably get sick of us talking about it and hearing about it, but that's why we monitor it so close, because the MJO pretty much drives everything, and if you can see the MJO turning a certain way, for 3 weeks it's either going to be good or bad. In this case, we're in the middle of the 3-week bad window, so not so good. We're into Thursday, Friday here, just no hope. And then as we get into Saturday, well, not sure if that is anything yet, but then look at this. You start to see what looks like a trough way to the south. This is on Saturday night into Sunday, and then you get something that almost looks like a legitimate trough with 160 knot winds pushing north. So there is some hope out a week out. If you believe any model a week out, we don't, but it offers some hope. We'll take it. So let's take a look down at the surface. Surface level pressure, surface level winds. No big surprise. High pressure here, 1030 millibar high, pushing south almost to Antarctic ice right around here. No surprise. And then we remember that we had that trough that was trying to organize here, and here's a gale. Well, not even a gale yet, just low pressure, 30 knot winds. Got to have 35 knot winds to even be qualified as a gale. And it just doesn't happen. That trough pinches off into Monday, and okay, there you go. Now you're a gale with a tiny area of 40 knot winds outside of the Southern Cal swell window. Maybe good for a little something for Mexico at best. There you go. Yeah. But the greater South Pacific, massive ridge here, just no hope for anything happening. Then something, what's that, a little gale Thursday, but again, not enough winds. I mean, you really need 40 knot winds or better to get swell reaching the whole way up into, and there you go, 40 knot winds on Friday and lifting a little bit to the northeast. Not bad. And then underneath the Tasman, south of the Tasman Sea as we get into Saturday, things looking very much interesting. A broad area of 45 knot winds, building, pushing well to the northeast into Sunday, fading a little bit as we get into Monday, but that sort of smells like a significant change in pattern. All right, so what's the effect of those winds on the ocean surface? That's what we're really here about, right? Surf? All right, so let's get into it. We see nothing going on. Remember that little trough, a little bit of a low. We expect something to build. There we go. 27-foot seas. I mean, this isn't really any hope for California. Mexico, Peru, Central America, yes, they'll do okay from that. Chile, not so much anything in our forecast area. Another little gale tries to organize. We saw into Friday, maybe a tiny area, 28-foot seas lifting northeast. So yeah, maybe some swell about a week out from that, a very south-angled swell. And then under New Zealand, as we get into Saturday, things start getting interesting. 42-foot seas. Sorry, let's see, 52, 105. That's right here. That's out of the California swell window. So, but 42, 43-foot seas, building to 44, 40, something like that, 45 feet, and making some headway, covering a large area. So, sort of looks like the inactive phase of the MJO might be dying off, just looking at the models, literally having not looked at the long-range plan, but things looking a little bit better here. But until then, let's try to figure out the wind swell situation. All right, high pressure, no big surprise, locking down the eastern Gulf of Alaska. Pretty typical this time of year that there is low pressure still pushing in. You know, you would say, oh, this is interesting. Yeah, this is the remnants of winter still working its way through the Gulf of Alaska, weak remnants, and it's not till you get about mid-July that you can really say, all right, winter is over, and it's all about summer now. All right, but anyway, high pressure, creating a pressure gradient, heat low inland, 20, 25 knot north winds off Cape Mendocino, generating tiny, small, northwest wind swell into exposed breaks in northern and southern California. A little bit of easterly fetch east of the Hawaiian Islands, 15 knots. That'll make some small, 7 or 8 second period wind swell along east-facing shores of the Hawaiian Islands. So we get into Monday, the gradient starts building, high pressure building, 30 knot north winds. That certainly will generate wind swell down into central California. Easterly fetch here starts building east of the Hawaiian, same drill, more wind swell there. And then as we get into almost Tuesday, we're talking 30 to 35 knot winds. Now, here's the deal. That looks pretty impressive, but we get this eddy flow, the low pressure action. So you have high pressure here. The heat low inland actually pushes off the coast, so you don't get quite as much wind swell as you'd expect because the fetch is actually running out over open waters, not pushing down into the coast. But you get cleaner conditions. You get south winds along the coast here. So wind swell and fetch off of this, almost making it the whole way to Hawaii. So wind swell for Hawaii. There you go, into like Tuesday night. Looking pretty decent there. As we get into Wednesday, same drill. Fetch, wind swell for Hawaii as well. So we get into Thursday. The gradient continues, still making wind swell. Less so for Hawaii, but swell from the past 2 days fetch still continued to radiate into the Hawaiian Islands, and then slowly fading out. So we get into Friday, the gradient sort of rebuilds along the California coast, but starting to fall south, as you see here. Fetch building, that means bigger wind swell in this area. Nothing really for Hawaii. And into Saturday, more wind swell for California. And into Sunday, now it looks like the high is building in earnest and probably will consume the entirety of the California coast. And there you go by Sunday night. That's a week out, though. Also looks like potential for wind swell for Hawaii, though, too. There we are, 180 hours out. Strong high pressure just building in, completely filling the Gulf. No signs of low pressure. All right, so let's go take a look long term. What's going on with the MJO and El Nino? As usual, we like to look at winds on the equator in the West Pacific. This is the East Pacific here. This is the West Pacific here. That's New Guinea. There's the date line running right there, 180 west, and that's the equator. So this is the entire equatorial Pacific on one chart. This data, compiled from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is 5-day average wind, so it's not super sensitive. It's not like what's happening right at this moment. It's the average over the past 5 days, and that's good enough for monitoring El Nino and or the MJO. And winds are from the east, not unexpected. Strong, solid trades over the eastern and central Pacific and into the West Pacific. So you go, well, that certainly isn't active MJO. It looks like inactive MJO. And the anomalies, differences from normal for this time of year. Pretty much normal. You don't see any arrows in here. That means these east winds are normal. A little bit stronger than normal, maybe right in the central Pacific. And kind of a mixed bag. There's a little, say, generally easterly over the Kelvin wave generation area. That area, 135 east to 170 west, 5 degrees north and south of the equator. You draw a box in it. And this is the area we use for looking at the presence of the MJO, right here in the West Pacific. And right now, this data looks like inactive MJO with east anomalies. If it was active, you want to see westerly anomalies. But remember, these are 5-day average winds, so there could be changes here. And because it's a 5-day average, the average hasn't figured it out yet because we're too early into the change. Keep that in mind. And what have winds been doing the past 5 days? So June 10th, that was Monday. Again, Kelvin wave generation area, there's our equator. There's South America, Central America, New Guinea right there, Australia, Philippines. Kelvin wave generation area, 5 north to 5 south, right about in a box around here. You see the arrows from the east in the blue. That's easterly anomalies, so that's inactive phase of the MJO. We just go day by day. No big change there, though starting about the 14th, it looked like it was getting a little bit weaker, but definitely this looks like inactive MJO territory. Then we look at 850 millibar zonal wind anomalies. Same sort of drill. This is a different chart, though. This shows over time. So here's May, moving to June. Kelvin wave generation area between this tick mark and this tick mark. So you just go right up. You see where there's reds. Well, that was in the Kelvin wave generation area. That was our last active phase of the MJO. It ended about the end of May. Then blues pulled in into the Kelvin wave generation area. That means easterly anomalies. That means inactive phase of the MJO. And the inactive phase of the MJO, as we know, tends to stomp on the jet stream and squash storm development. But then, June 16th, that is today. That's right. You see, well, what's this? We see, now here, you can, well, we see oranges and reds. It was actually a little bit stronger looking yesterday, but it looks like the active phase of the MJO is trying to set up, and about a week from now, on the 22nd of June, it'll be filling probably 2/3 of the Kelvin wave generation area. You can see strong easterly anomalies, but they're not in the Kelvin wave generation area. Once they move out, 170 west is the cutoff, right about there. Once these winds move out of the Kelvin wave generation area, they start having a much less of an impact on the jet stream. And that's exactly what we want to see. So remember, we saw that big low pressure system forecast pushing under New Zealand a week out. Well, why is that? Because the active phase of the MJO potentially is to be building in the far west Pacific, at least according to this model. All right, so let's look 2 weeks out. This is another MJO model, but instead of wind anomalies, it's outgoing long wave radiation, cloud cover basically, okay? And the active phase of the MJO is basically like a big low pressure system, and the inactive phase is like a big high pressure system. If you have low pressure, you tend to have more rain, and this blue means negative anomalies. Notice the number, basically less sunlight reflecting off the ocean surface, more cloud cover. Okay, so it looks like, and that is the active phase of the MJO. Of course, our main area, the Kelvin wave generation area, is a box right about in here in the West Pacific. So it looks like even today, active phase of the MJO is trying to set up in the West Pacific, looking much better, this per the statistic model, 5 days out, 10 days out looking good, then weakening a little bit 15 days out. The dynamic model, a little bit better setup here, showing, there we go, showing the active phase in the Kelvin wave generation area, pretty solid 5 days out, holding at 10, holding at 15. And this is what the model showed yesterday too, so it's holding pretty steady. The dynamic model, a little bit more in our favor than the statistic model, and that's not unusual. So here are our phase diagram charts, another way looking at the MJO, sort of how strong it is and its position where the active phase is. So assume this is the North Pole, you're looking down on the North Pole. The MJO goes from west to east around the equator, from the Indian Ocean to the Maritime Continent, over the West Pacific, underneath the United States, across the Atlantic, over North Africa back to the Indian Ocean. The MJO travels round and round the planet, both the active and the inactive phase. Where the heavy dot is on the 15th of June is where the active phase is. So it's right over the maritime continent. The further away from the circle, the stronger it is. So we'll say modestly strong. And the forecast is for it to move into the West Pacific over the next 15 days, but getting weaker, this per the statistic models. The dynamic models suggest it also moving right to the edge of the West Pacific and moderately strong, then backtracking. So, hard to say. A little bit of a difference here between the two models. But either way, it's getting closer to where we want it to be in the Kelvin wave generation area, which would be generally in this area right here. The upper level model hasn't updated since Monday, so we're just going to pass by that. This is, again, one of those charts where the whole planet is on one chart, Kelvin wave generation area between these two tick marks, back in time here, so you can see where the dotted contours are the inactive phase, and this is the Kelvin wave generation area right down the middle of the chart here. In May, here was a big active phase, pretty solid. Westerly anomalies, the reds, westerly anomalies. Here's our inactive phase. This started about, we'll say early May, but didn't make it into the Kelvin wave generation area till about June 1st. It peaked in the Kelvin wave generation area maybe 5 days ago, and it's pushing east. But you can see it's already almost out of the Kelvin wave generation area by another 3 days. It'll be gone. Here comes the active phase of the MJO behind that. This looking not quite as strong as it looked a day or two ago, but still pretty solid. Anything that's not inactive, if it's active, we'll take it. But the good news is, after that, even after the active phase kind of passes, the whole way into July, westerly anomalies in control. We think that's associated with El Nino. And then there's the 3-month CFS model. Now this switches the dates around. Past history is down here. Kelvin wave generation area, basically between these two tick marks. You see a big active phase there in February. Westerly wind anomalies. Here's the last active phase that occurred in May. Decent westerly wind anomalies. And you can see, well, it certainly looks like another burst, westerly wind burst, smaller. Here's the MJO. Let's overlay it. So here's our inactive MJO that we're in. We're going up this time. Now this one says, okay, the inactive phase isn't out of the Kelvin wave generation area, 170 west, till about June 24th. But even at that, westerly anomalies are supposed to start building as of, we'll say, tomorrow in the Kelvin wave generation area, getting pretty solid by June 24th and holding. And look at this, 1, 2, it's almost like 3 active phases of the MJO kind of lined up. It's probably the same active MJO from, we'll say, June 18th into about September, the whole way through summer. Really? That's good if that's the case. Kind of hard to believe, but we'll take it for sure. And then a little bit of an inactive MJO trying to set up, but not even really setting up as we get into September. Now remember, we're out of the spring unpredictability barrier, so maybe this model is getting a better handle on things. Let's overlay the low-pass filter, see what's going on here. All right, so what is this black line? This is basically a low-pressure bias. If it was a spotted line, it'd be a high-pressure bias. And the black line, if it's solid, low-pressure bias in the Kelvin wave generation area means only one thing, El Nino, or some weak flavor of it. And you can see we had 3 contour lines into about April, and then we were down to 2, and that's going to disappear in the next couple days. Then we're down to 1 contour line. So if you thought El Nino was weak last winter, it's even going to be weaker still. But the good news is it is at least supposed to hold. You know, I just noticed something that's a little bit interesting here. Westerly anomalies, there's the line, and there's easterly anomalies here. And that line kind of coincides with the backtracking of the low pressure bias line here, moving into, well, the Kelvin wave generation area ends right there. So it starts encroaching on the Kelvin wave generation area as we get into August. And notice this black line here, the low pressure bias setting up in the Indian Ocean, and the one that's in the Pacific appears to be retrograding over time. I mean, where is this going? Well, I don't know. I'm kind of thinking maybe La Nina as we get late into the season, but hard to say. too early to know. All I know is westerly anomalies are supposed to be in the Kelvin wave generation area, but limited to the western Kelvin wave generation area as we approach fall. That's still good. Plenty of momentum in the atmosphere. Still the same sort of drill like last year, where we're saying, yeah, probably support for storm development would be pretty good in the fall and maybe into the early winter months according to this, but January, February, a little bit questionable right now. Precipitation for California, definitely questionable. All right, that's enough about the MJO. Let's go take a look what's going on in the ocean. This is really what's happening with El Nino. West Pacific here, East Pacific here, TAO buoy array. Here's the anchor lines on the TAO buoys. The X's are the sensors on the anchor lines. They collect data. They beam it up via up to satellites. Satellites beam it over, I think it's over in Washington, D.C. area somewhere. And all the data gets crunched. They run through a model. They fill in the blank spaces, and you get a picture like this. So this is actual temperatures. 30 degrees has actually grown quite considerably in the past couple of weeks. This is 30 degrees centigrade. So building surface temperatures here in the West Pacific. The 29 degree isotherm line, though holding steady about, it was 55, now it's at 157 west. The 28 degree isotherm line, it was at 140, at 142, so it's sort of backtracking a little bit. And the, the 24 degree isotherm line has been pushing, it was doing this number the whole way into Ecuador and down at about 25, 30 meters. Now it's retracted from the coast. It's at 105 west. Sort of seems like, at least for the moment, temperatures are cooling or there's not as much push of warm water off to the east, a sign of a weakening El Nino. But then you look here, this is anomalies, differences from normal for this time of year. The whole Pacific, equatorial Pacific, full of warmer than normal temperatures, 2 degrees above normal. Looks like another Kelvin wave has formed, and it's pushing off to the east. And we did have cool water here. That was what was probably driving this. But it looks like warm water is pushing east. So, again, what's a Kelvin wave? Well, active phase of the MJO in the West Pacific. Remember, we were looking at those winds in the West Pacific. If you get westerly anomalies, that's the same as like westerly winds. It takes warm water, like that warm water that's there, starts pushing it off to the east, forms a bubble of warmer than normal water, just like here, 2 degrees above normal centigrade, and that eventually works its way off to the east. And under the best of circumstances, if the winds are strong enough, long enough, and there's enough warm water, it erupts along the coast of Ecuador. But if it's not strong enough, doesn't have enough momentum, it starts bleeding up, further west. Like in this case, this looks like, where is that? 120 west, so about south of California, and sometimes even further west than that. And when it does that, when it doesn't like fully slam into the coast of Ecuador, it's called a Modoki El Nino. Sort of El Nino, but not really. You need all that warm water building up in the far East Pacific to get a true legit El Nino. And subsurface-wise, this doesn't look like that's happening. Let's go look at another model here. Yeah, it's even more pronounced here. This is from June 12th, so a little bit older. But you get the idea. Yes, good ball of warm water here. But most of it, I'm just looking at it from so basically south of Hawaii to a point, maybe down into like Baja or something like that, south of Baja. Okay, and cold water, upwelling phase of the Kelvin wave. So once you get a Kelvin wave erupt, then you get some cool water that gurgles up. We think this one, it'll probably make it into here somewhere, but it's not going to make it the whole way to Ecuador. None of them have this year, and you'll see that in a minute. Anyway, still, there's 3 months of warm water in the pipe. So what is this? Middle of June to July, August, September. So middle of September before everything taps out at least. And then another 3 months after that, so September to October, November, till December, before you would really get any serious manifestation in the atmosphere or anywhere else of anything that's not El Nino. So the El Nino signal, we think, is going to hold through the end of the year. Okay, upper ocean heat anomalies. So this is West Pacific here, East Pacific here, and all you're doing is watching Kelvin waves push across. This doesn't happen all the time. If you've been following this for, just the past year, we've been under El Nino. So you see one Kelvin wave back last year in, what was that, the May, June time frame. Here's a strong, was this Kelvin wave number 2 that developed westerly anomalies in the West Pacific. Warm water here, you can see it, pushing off to the east. Ecuador is over here somewhere. Didn't make it to Ecuador. Most of the heat stopped somewhere south of California and gurgled up. Upwelling phase of the Kelvin wave cycle. Kelvin wave number 3, same drill. A little bit stronger in, when was that? January, February, March of this year. Here's our upwelling, oops, here we go. Here's our upwelling phase of the Kelvin wave cycle. Here's our last little baby Kelvin wave. We'll call this Kelvin wave number 4. Might be number 5, but we'll call it number 4. You see the amount of warm water associated with it cannot compare to the other 2 that were before it. You also notice there's cool water building over here in the West Pacific as compared to warm water that was there earlier. So there's just not as much warm water. No matter how many westerly wind bursts you get here, you're not going to get a big Kelvin wave. And that sort of means that El Nino's tapped out. Figure, again, this will all bleed out as we get into the fall. And then the question is, what happens after that? Do we go neutral or do we go to La Nina? We'll see. Upper ocean heat anomalies for the whole area from like south of Mexico to the date line, but it gives you a vague indicator of Kelvin wave activities. Bump there, and you notice now here's our next little baby Kelvin wave, but not nearly as much. You can see energy tapping out. Sea level anomalies. Okay, what is this? It's just another way to get a sense of what's happening subsurface on the equator temperature-wise. Okay, warm water at depth expands, creates a little bump on the ocean surface. Cold water contracts, causes negative anomalies. So what do we have? Here's the equator. South America, Central America, Australia, you get it. Date line right there. Kelvin wave generation. We're not worried about the Kelvin wave generation here. We're just in the Nino. So the Nino 1.2 region is here, this area, right off of South America, Peru, Ecuador. Nino 3.4 from 120 west to 170 west, right there. And we see a 0 to 5 centimeter positive bump there. This means there's warm water underneath that region. Kelvin wave in flight, but not much of one, and not a very strong one. And all we care about is 5 degrees north and south of the equator. So, yeah, a little Kelvin wave in flight there, but no big deal. All right, let's go take a look at sea surface temperatures. If you have Kelvin waves and they eventually erupt, well, that should manifest itself in terms of as warm water on the ocean surface, and that's what helps get El Nino started. So there's Peru, there's Ecuador, there's your equator right there, there's Mexico, okay, and the reds, you can see it, are positive anomalies. Warmer than normal temperatures, we see a pretty good pool of warmer than normal temperatures, so we see cooler than water temperatures along Peru. In fact, that area of cooler waters was much bigger earlier this week. It's faded. And last week, the area of warm temperatures was much stronger up in here. That's fading too. So we just have this generalized, what do you say, maybe anywhere from a half to 1 degree above normal, but though definitely warmer in pockets. But it's not till this warm water gets pushed by the trades over here, 120 west, 5 degrees north and south of the equator. This is the official El Nino monitoring region out here. So we had generalized, maybe 3/4 of a degree above normal right out in here. Hard to say, but that's what it looks like. And then that continues off over to, well, filling most of the Pacific. But what you really want to see is a big, strong signature right here, and we're not seeing that. The trend for the past 7 days, weak warming along Peru. Stronger warming here, just north of the equator. Yeah, but it was cooler over here, I think, last week when we looked at this. So it's warming, but that's only helping it get back to normal. And no big clear signs of any major warming trend. If anything, just everything holding kind of neutral. No clear signs of a building El Nino pattern at all. And then here's the actual sea surface temperatures anomalies. The Nino 1.2 region right here, warmer than normal, but nothing marked. Here, the official ENSO El Nino, the 3.4 region, Nino 3.4. Yeah, a little bit warmer than normal, but you kind of look here, the whole equatorial Pacific is warmer than normal. And in fact, all the Pacific is warmer than normal. This is kind of interesting, though. Cool water pushing this way, a warm front building off the coast, if you're looking for the warm phase of the PDO, that's exactly what you'd want to see. Maybe not so much in summer, but in the winter. And why is that? Well, if you have a whole bunch of low pressure systems moving this way, they mix up the ocean. You get a cold front hanging right here. That takes warm water from down here, pushes it up here, and that's what sets that kind of signal. So this, if you were just looking at it for a single day, it's something we want to look at for weeks and weeks and months. But it kind of looks, for the moment, like the warm phase of the PDO. And if you've been following this at all, when you get warm PDO, that's like an El Nino that goes for 20 years. And we're in a multi-year weak El Nino now. That's not to say there can't be La Ninas during the warm phase of the PDO, but maybe a sign, something to keep an eye on. So what's going on in the atmosphere? Is the warm water on the equator in the Nino 3.4 region having any effect on the atmosphere? Just because it kind of looks like El Nino in the ocean, the atmosphere has to respond. So one way to look at that or monitor is through the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. If the index is negative, meaning you have lower pressure over Tahiti than Darwin, that suggests El Nino. If it's positive, then you're La Nina. Today's contribution, minus 3.6. And what's it been? It's been actually positive. And I'm going to go back in time. You see, this looks like in May, there's a bunch of good negative numbers. This is probably the active phase, the MJO. Then here comes our inactive phase that's occurring now. And then just past this, it'll probably start going negative again as the new active phase builds in. The 30-day average, another way to sort of sort that out. Okay, there we see we went down to minus 9.4 in early June. That was the active phase, the MJO. And now the index is, well, it's rising a little, but not a whole lot. So no clear signs, particularly here in any strong active phase of the MJO, or for that matter, any strong inactive phase of the MJO. 90-day average, today minus 4.39. What's it been? It's been hanging between 4 and 5 for a month now. If it was El Nino, this would be down around 9, 10, or preferably 15 or 20. In fact, let's go look at the 30-day average. All right, so here's the 30-day average. Today's value, minus 6.5. According to this index. So these downward spikes are the active phase of the MJO. That's the inactive phase of the MJO. So here was an active. Here's our current inactive, and we expect this to start turning and starting to fall maybe in the next week a little bit. But you get the general trend. If you want to see El Nino, all these values need to be down below zero in the minus 10 to 15 range. And so we can go back in time. January 2017. Here was our sort of our La Nina back in 2017, early 2018. And here's the beginning of our this recent weak El Nino, and you can see it's very weak, sort of toggling right around the zero line. Yeah, it went strongly positive, then strongly negative, still hanging around minus 5, not much of an El Nino. And we forgot to show, this is actual temperatures in the Nino 1.2 region, that area right up along Peru. Today the values are half a degree, 0.556 above normal. You can see there's no real trend in this. It's pretty noisy, but it's not going down, it's not going up. It just has its moments, but it's hovering, I'd say, just above zero for an average. Nino 3.4 now, this is the official El Nino monitoring region. Today's value, 0.709, and it's been roughly in that area for weeks, dipped down to about half a point there, half a degree above normal, but has been steady at about 0.6 or 0.7 for months now. And so this is your sign in the ocean of weak El Nino. But again, looking at the SOI index, nothing particularly clear there suggesting any strong El Nino. And then finally, the Nino 3.4 sea surface temperature anomaly forecast for months now. This is going out to next year. You can see pretty much a flat line here at 0.75. So remember, today is what, in June? We're here. And there's literally no difference as we get into March of next year. So this model And the consensus model of a whole bunch of other El Nino models are suggesting that this weak El Nino pattern is to continue for the foreseeable future, the whole way through this coming winter. We're kind of scratching our heads a little bit, though, looking at the Kelvin wave situation, just going, there isn't enough warm water anywhere unless some miracle happens to keep these warm temperatures at this level. We personally think this will go till about, somewhere around September or so, and then temperatures are going to start dropping and slowly fading. But hey, we could be wrong. You never know. All right, so to put a bow in things, and actually sitting here thinking about it, we forgot to go back and look, but there are 2 southern hemiswells in the water. The first one is just starting to hit California now. It's been hitting Hawaii for the past 2 days. Some from a system under New Zealand. Pretty nice, moderate-sized swell expected from like real southwest kind of angle. And so that should go through the first part of the week. Another system pushed under New Zealand after that. That should set yet more swell up, mainly for California, kind of bypassing Hawaii. This one was aimed very much to the east. For the latter part of the work week into the early part of the weekend, then things die off for a little bit, and we're kind of keeping our fingers crossed, hoping that that other system that we saw on the forecast charts a week from now materialize, then that could help set us up with more southern hemiswell. In the meantime, plenty of wind swell for exposed breaks in both California and Hawaii. So, and beyond that, well, weak El Nino to continue for the foreseeable future. Odds are unknown what's going to happen, but certainly through the early part of fall into mid-fall. By the time we get deep into winter, it's debatable whether we'll still be in El Nino, but certainly the first half of the season looking pretty good. So that's it for this week. We'll do this again next week, same time, same channel. Thanks for watching.